Hi everyone, this is Lesson 2, Unit 2. The objective for today is students will be able to determine the basic elements of an experiment by analyzing real-world experiments and identifying the independent and dependent variables. Experimentation. So in the last unit you all talked about survey, you talked about naturalistic observation, and you talked about case study. Today we're going to focus exclusively on experimentation. Experiment is a research method in which an investigator manipulates one or more factors, which would be considered the independent variable, and they do this in order to observe the effect on some behavior or mental process, which we consider the dependent variable. How can this help us? Well, when we talked about correlation, we talked about how two things might be related, but it doesn't necessarily mean cause and effect. Experimentation can help us isolate cause and effect, so we can actually determine what is causing the other. It can control factors that we can't control in the natural environment. We can also manipulate certain factors, like let's say we want to see how people behave in temperature. We can cause the temperature to increase or decrease. We can also hold things that are consistent. So maybe we want to see how people act in temperature, whether it's hot or cold, but we want to eliminate other things that might typically come with that. So for example, maybe we want to make sure that everybody is still well fed, even though they're hot or cold. Or maybe we want to make sure that they are comfortable, even though it may be hot or cold. So we can control for certain factors. Oh, sorry. So that is experimentation. Experimentation, random assignment. Random assignment eliminates alternative explanations, but it's different than a random sample. So random sample is when you choose people randomly to study. In this case, we've already chosen those people. In this case, we're just randomly assigning them what group they might be a part of. So they've already been chosen, but maybe we are randomly assigning them control group or experimental group, or randomly assigning them if they're going to get the actual drug or the placebo drug. And what this helps us to do is to eliminate alternative explanations. So if we randomly assign people, then they can't say, oh, well, you chose all the, smart people for the drug, or you chose all the women for the drug. If you just are randomly selecting people, or randomly assigning people, not selecting, if you're randomly assigning people, that eliminates anything alternative and allows for a more equitable experiment. The blind form of this means that you're uninformed. It means that if you do this blindly, you don't know who got put into what group until after the experiment is over. And you can do two types of blind experiments. You can do a single blind, which just means that the people who are participating are blind to what's happening and who's getting what treatment. Or you can do a double blind, and this is where both the people who are participating and the person doing the research are both blind. So for example, I may have a separate coworker give me two sets of drugs. One is drug A, and that's the drug itself. One is drug B, and that's a placebo. But I don't know what is what as a researcher. Then I randomly assign drug A or drug B to individuals in my group. They don't know if they're getting the drug or the placebo. The positive behind this is that, again, it will eliminate any alternative explanation. So I can't give the healthy people the drug or the young people the drug because I'm randomly giving it to them and I don't know which one is the drug and which one is the placebo. Placebo effect is when you give somebody a placebo, so you're telling them they're getting the treatment, but really they're not. So for example, they might be getting a sugar pill. But the placebo effect is when you see results that are caused purely by expectation. So for example, when my daughter says that she's hurt, I tend to give her lavender. So I mix lavender into lotion and I put that on her and I say, there's your medicine. Well, is it medicine? Not really. I mean, it is lavender, so it's a calming effect, but it's not really any medication. but she says that she feels better because of that. So that's a type of placebo effect. She expects to feel better when she gets medicine. Grouping. We've already talked about this a little bit. There's two types of groups. There's experimental group, and this is a group that you're testing. And they're the ones that receive the treatment or the independent variable. Excuse me. And then you have the control group, and that is the one that will not receive the treatment and will, in fact, receive the placebo. Independent and dependent variables in experimentation. This is really what we're trying and really what we're testing. The independent variable is the experimental factor that is manipulated, the variable who's being studied. Part of this is confounding variables, and this is a factor other than the independent variable that might produce an effect in the experiment. So this might be something that might impact our results without it intending to. Hopefully by random assignment, that eliminates this possibility. That's the whole goal of doing random assignment, is to eliminate that. Then you have the dependent variable. The dependent variable depends on the independent variable. And this is where the outcome factor, the variable that may change in response to manipulation of the independent variable. This is what I am measuring right here. Sorry, let me go back to this one more time. We are going to be taking a look at a variety of different examples of this. But the independent variable is maybe I want to give study time. If you study longer, you get higher test grades, right? If you get more sleep, you get higher test grades. Those would be the independent and dependent variables. Random assignment. So we have two groups. This is how we design an experiment. We have your experimental group and your control group. I randomly assign them, so I don't know who's going into what. It's just a random thing. And then I have an independent variable. I give the experimental group breast milk, and I give the control group formula. And this is an actual study, by the way. The dependent variable, so depends on the independent variable, is an intelligence score of 8 and an intelligence score of 8. If this was actually accurate, then we would find out that there is no impact of breast milk versus formula on someone's intelligence score. And that is it for experimental design. I am going to go through one quick slide here. This is just something helpful if you want to compare research methods together. So if you want to take a look at descriptive versus correlation versus experimental, this is a better way to look at it if you want to compare and contrast it.